at number 2 on y'all's paper, it says you have a charge of -1, a mass of 8. We decided, it told us it didn't have to be stable, but we're going to make this one stable. So we're going to start with a mass. If it has a mass of 8 and we want it to be stable, then we need to have equal protons and neutrons if at all possible. So we're going to go ahead. Okay, that's going to be 4 protons, 4 neutrons. That makes it stable. What if we wanted to make it not stable? What could we have done? Okay, so if we had like 6 and 2, which one would we have 6 of to make it not stable? Protons, because that makes it very, very likely that they're going to be touching. Okay, so, but in this case, we're going to make it stable. So it's got a mass of 8. So that's that. And then electrons, it's going to have a charge of -1. We can't, once we decide the number of protons, we can't change the number of protons to make the charge whatever it needs to be. So if this was a neutral atom, it's going to have 4 electrons, and we'd have equal protons and electrons, but this one has a charge of -1. So there's a mathy way to do this, and then just let me think about this and figure it out that way. What's it going to be, Hunter? It's going to be 5 electrons, exactly. So you basically just take the atomic number, or the protons, and you subtract the charge. Okay, that's going to equal the number of electrons you need. So if some of y'all are overthinkers and you need a formula to follow so you do not overthink it, then this would be good to copy. If you're just good at just like logical, like that just makes sense, what Hunter just said, then you don't have to do it this way. Electrons are negative, and to make it a negative charge, you're going to add electrons. You're going to subtract electrons if it's a positive charge, or you can just follow this. All right, now we know what we've got here. We just need to draw it. So our atom is going to have rings. Before we do the rings, let's do our little protons and neutrons and electrons. So let's color in the protons. Make those colored in circles. Neutrons are open circles. So we need 4 of each. So guess what? We just don't do 1, 2, 3, 4, 5, 6, 7, 8. We need to draw this in a way that it looks stable, because we already decided we wanted it to be stable. So what cannot touch? The protons. So guess what? Here's how I would do this. I like to work smarter and not harder. So y'all look up here. Here's what I would do. I need 8 little things in my nucleus, right? 5, 6, 7, 8. Okay. Now I'm just going to color in every other one. All right. So I need 1, 2, 3, 4. And it's okay if they're kind of diagonal, but we don't want them like directly above and below or side by side. Diagonal's getting a little tricky there. So there's our mass of 8. Protons and neutrons don't touch. Now we got to do our electrons, and they're going to be on rings. So the main thing that I need y'all to know, guys, is only 2 electrons on the first ring. Okay? So you can make them X's, or you can make them circles. Totally up to you. How many of y'all would do circles?
Circle with an X in it.
Or a circle with an X. All right, that's kind of a little extra. But 2 electrons here, so we have 1, 2, and then 3, 4, 5. That's it. So any questions about this? So 2 electrons on the first ring. We'll get into more details in the electron unit, but how many do you think maximum would go on the next ring? 8. 8 is our magic number. It is the magic number of electrons. Has to do with keeping it stable and all that stuff. So stability of an atom's nucleus has to do with neutrons and protons, but the reactivity has to do with those 8 electrons. Okay? But y'all just need to remember on the first ring, 2 is the maximum, and then 8 is the maximum thereafter. All right, we're almost done. We needed to answer which element is this. How do we identify elements again? On the periodic table, do we look at the atomic number or the mass number? Atomic number. Okay, it's the atomic number, which is the protons. So remember, the mass can vary based on the isotopes. So the periodic table has the average of all the isotope masses. It's actually a weighted average of all the isotope masses, but this isotope has a mass of 8, and it might not match what you see on the periodic table. But element number 4 is what? Beryllium. So this is beryllium. You can write the symbol or its actual name. Okay? And I think, does beryllium have a mass of 8, or is it like 7 something?
9.
Oh, so it's 9. So that most stable isotope had a mass of 9 and not 8. Okay? All right, so y'all just work on this sheet and I'll walk around and help y'all. All right, so if you needed to know how to figure out the number of electrons, there's some numbers plugged in for what we just did on this example problem.